Now that we've talked about synchronized collections and discussed their pros and cons, let's turn our attention to Java concurrent collections. And we'll again talk about their capabilities. They don't really have a lot of limitations. They're really very powerful and very cool. And we'll talk about how the concurrent collections in Java overcome the limitations we discussed earlier with Java's synchronized collections. So Java, as of Java 5 and later, have been adding many different concurrent collections. And what they do is they take old-fashioned data structures like hash maps and so on that have been around for a long time, and they sort of beef them up and bling them out to optimize them for the needs of concurrent programs. They also add some new collections that weren't there before as well. But we're particularly interested in comparing and contrasting the behaviors of synchronized collections with concurrent collections. One thing that makes a concurrent collection more powerful, as a general rule, is it's thread safe, like a synchronized collection, but it's not governed by only a single mutual exclusion lock. And the way that they work, of course, is because they're done in a very clever way by some people who are very smart in the ways of concurrency and synchronization. They ensure that we don't have inconsistencies between memory in different caches in, say, multi-core processors by defining the appropriate happens before relationship. And we've talked about happens before relationship earlier. And basically, if you recall, it's a guarantee that memory writes in one thread will be made properly visible to other threads that read the changes. And just as a simple example, using our good friend array blocking queue as an illustration, it means if you have one thread that's adding things to the queue and another thread that's pulling things out of the queue, then you won't have to worry about inconsistency between the updates and the reads later, because it's all handled properly by the appropriate synchronization under the hood. The other thing that some of the concurrent collections do that go above and beyond just the simple concept of happens before relationships is they also enable the desired behavior on blocking queues that happen to be empty or full. And so as you can see here, when you do a put on a full queue, it'll block till it's not full. When you try to remove something or do a take on an empty queue, that call will block till it's not empty. And of course, there are timed versions of this stuff too, but we're focusing here just on the concept of synchronization. So that's a really quick overview of Java concurrent collections. As before, this is just here to give you a high-level perspective on what's happening. The real interesting part, for my money, is what we're going to talk about next, which is how these Java concurrent collections can be applied in practice.